What's up everybody, how's it going? Welcome to my channel codedoctor. I am Saurabh Saxena, working as a full stack developer at booking.com, Amsterdam. Today we're going to talk about how to crack system design interview at Amazon, Microsoft and Facebook. These tips are really going to be helpful if your system design interview is coming up soon, and I'm sharing these tips from my personal experience where I did crack the system design rounds at these companies. So let me walk you through with all the 5 steps which are needed to crack the system design interview. So let's start. The step number 1 is finding a peer to practice with. It's really important to have a peer when you're preparing for system design interview. So you can look for a friend who are preparing for the same system design interview, or it can be your colleague who are really interested in discussing the architecture problems. So make sure you should have a peer to practice with, because when you have a discussion around a problem, you will actually explore a lot, and you can see the differences when you actually take a problem and try to solve it on your own, and compare to having a peer where you will have mutual discussion where he will be not agreeing and you will be not agreeing. Then you look for a better solution and better approach. So the first step is very, very important, to have a peer practice peer for you. If you don't have one, then you can look for some platform like Pramp. So Pramp is a platform where you can schedule mock interviews with a random peer with the same interest. So let me walk you through what Pramp really is. So you can go to pramp.com, create an account, go to practice session, you can choose system design, and in the next you can choose a slot whichever fits you. Let's say I choose 5 AM on Thursday, confirm and schedule. Then Pramp will find a match for you. So this is your interviewer assigned to you at 5 AM, and yeah, so this is the question that you're gonna ask, and there will be a random question assigned to your interviewer which he gonna ask you, right? So there are hints, there are answers. You should be better prepared to ask question to your interview, and this is the feedback where every interviewer can give you the feedback after the interview, so you know like what to work. So let's be real, because things will be very complex, or you will be demotivated if you're preparing alone for system design interview. So having a peer with the same interest will help you a ton. So make sure you should have a friend or a peer, which can be from online platform, to practice it. So that's the first step. Now, what's the step number 2? So the step number 2 is know basics. You need to know few basics even before start practicing. I'm going to give you a very high level intro to all the concepts which you need to know before even start practicing. Please subscribe to my channel for future updates on detailed overview of each concept that we are going to discuss now. The first is a load balancer. So what is a load balancer, or what is load balancing? It's a type of reverse proxy that distributes the traffic across servers. Load balancers can be found in many parts of the system. It can be from DNS layer to all the way to database layer. So if you want to distribute the traffic among the database layer, you can have load balancer there. If you want to distribute the traffic among application server, you can have a load balancer there. So how a load balancer know like which server it should send a request to, right? So there are some selection strategies that involves, right? So a load balancer chooses server when distributing the traffic among multiple servers using techniques called round robin, right? So round robin is like you send a request to one server, then another server, then you again go back and send it to the first server and the next server again. So this is a round robin. Now there is another strategy called random selection. It can be a performance-based selection, like you can choose a server with the performance matrices like the fastest response time or the least amount of traffic, or it can be IP-based routing, which is used at the DNS layer. The next concept is caching. It's a piece of hardware or software that stores data, typically meant to retrieve the data faster otherwise. Caches are often used to store responses to network requests as well as computationally long operations. So when you say you need to know how many active users on your website is, instead of making query to your database, you can store that calculation or the operations in your cache, so that value can be retrieved constantly. The third concept is storage. There can be multiple type of storage. You can store in a RAM, you can store in a database. There can be a different type of disk. So you need to know the trade-off between the HDD or SSD, right? Fourth is network protocols, which is TCP and HTTP. So when you should use the TCP and when you should use the HTTP. Let's say when there is a chat, you're having a sockets, so your communication should be over TCP. When you're making a call to an API, let's say to get the user data, it just can be on HTTP. So understanding the use case and understand the network protocol which can be used therein. Next concept is latency and throughput. So what exactly latency is? The time it takes for a certain operation to complete in a system is called the latency. Or you can say the number of operation that a system can handle properly per unit of time, that can be latency, right? So throughput on the other hand is like you can say throughput of a server can often measured in like requests per second, right? How much the server is capable of processing queries per second or the requests per second, that can be the throughput. The next important concept is data partitioning. What data partitioning is? So you can partition your data based on different ways, I can say. Let's say you have today you have a million users. Now tomorrow you have a billion users. So you can store the users who are on a specific geography can be stored in one data set, or you can say in one specific database, and then the users for other geographical regions you can store in other database, right? So there can be partitions based on the behavior or based on the different attributes depending upon the problem or depending upon the situation, right? So data partitioning is very important to play a role when we talk about a distributed system, when we talk about distributed database. So next important topic is proxy, forward proxy and the reverse proxy. Forward proxy is a server that sits between the client and server and act on behalf of client, typically used to mask the client identity. Note that the forward proxy is just the proxy, right? And reverse proxy, a server that sits between client and server and act on behalf of server. It can be like load balance. It can be like typically used for load balancing or the logging or the caching. The next important concept you need to know about SQL versus NoSQL. SQL are databases which are like vertically scalable, and NoSQL are databases which are horizontally scalable. What does that mean? Like SQL are table based, while NoSQL are document based. They have a key value here, right? The next concept is long polling and WebSockets. Uh, the act of fetching a resource or a piece of data regularly at an interval to make sure that it is not too stale. So that's called the long polling. So you are just making a request after a certain period of time to get an update from the server. And it usually refers to act of continuously getting a feed of information from a server, you can say. Let's say in a Facebook news feed, there can be a long polling. So it will use an open connection between the two machines. It can be between the client and the server, and it will make a call to the server after some specific time. On the other hand, WebSocket has a continuous connection. It always connected to a specific socket on the server. So depending on the use case, when you should use the long polling and when you should use the WebSockets, it depends. When you are on a chat, you can use WebSockets, but when you want the news feed, like in a Facebook, you can use long polling. So these are the two important concepts which you need to know. And then here comes replication and sharding. The act of duplicating the data from one database to another is called replication. This is sometimes used to increase the redundancy of the system, or you can say increase the fault tolerance of the system, right? So when, let's say, there's one server fail, you have another server to as a backup. And the sharding is a process of splitting a database into two or more pieces, which is called shards. As we have discussed the data partitioning, it's actually the same thing. So it is done to increase the throughput of the system. So when there's multiple requests coming in, so let's say you have Facebook users coming from US, they can make a call to a US shard, and when users from India, they should be able to access a shard from India geography. So that's a shard. So it depends on, sharding can be based on different strategies, right? It depends on the type of data we are working with. It also depends on the client region. The next important concept is a rate limiting. So what is rate limiting is like, say, the number of requests sent from a client. We want to make sure the identity is authorized client to make a request to a server. Or let's say you have an API and you have exposed to the public, but you want to make sure those API should have a restricted access. Like no bot should be able to make the call regularly. So let's say that in 5 seconds you want to make people can access for 3 API requests, right? So you can rate limit. So why we do the rate limiting? The important uh, this features or important strategy that we use for servers is just to limit the number of incoming requests in order to prevent the DDoS attacks. The next concept is logging and monitoring. You can use Kibana for logging. So why we require logging is when we want to know the application behavior over a certain period of time, how the user is interacting, right? So logging is very important to actually debug the bugs as well as to know the behavior of a user, which can be used by a data analytics team, which can be used by uh, maybe developers to debug any issues in the production. So there are multiple ways you can logs. You can use Kibana for logging, and there are different monitoring tools as well. So there is a Grafana where you can just plot the graphs based on the data you capture through the Graphite database. Right. The next concept is pub/sub pattern. You need to know what a pub/sub pattern is. It's called publisher and subscriber, which is a popular messaging model that consists of a publishers and subscribers. Publish the message, or you can say publisher publish the message to the special topic. Sometimes we actually call it channels, without caring about or even knowing about who will read those messages. So, and the subscriber to topics read the messages coming through those topics. So there are different ways, there are different technologies like Apache Kafka, which can be used for a pub/sub pattern for a distributed system. The next important concept is leader selection. So what is leader selection? Let's say you have multiple servers and then one of the servers die. Now you need to make sure if the master dies, who will become the next master? So that's a leader selection strategy. So Zookeeper is often used to store the important configuration to perform such kind of leader selection, right? And the next important concept is MapReduce. So MapReduce, it's a popular framework for processing the very large dataset in a distributed system effectively and efficiently and in a fault-tolerant manner. So MapReduce consists of 3 basic steps. The first is a map, which runs a map function on the various chunks of dataset and transform these chunks into intermediate key value pair. And shuffle step, which recognizes, or you can say which reorganizes the intermediate key value pair such that the pair of same key are routed to the same machine in the final step. Then here comes the last step, is the reduced, right, which map a reduce function on the newly shuffled key pairs. I think it's a very complex topic for an intro video, but I will definitely come up with a detailed overview of MapReduce, how it works. So this is the GitHub, which has the basics concepts for the system design. I will be sharing this link in the video description. As you can see, they talk about performance, latency, and the cap theorem, right? So you guys can just walk through with that first, even before starting like with any of the question, right? So far we have discussed the 2 steps. The first is finding a peer. It can be a friend, or you can use a Pramp platform to look for a peer where you can be connected together later on. And then second step is know the basics. So I discussed very higher level overview of each and every topic, but you need to know that these are the terms you should be familiar, and then you can jump into the GitHub, which I'm sharing on down below on the video explanation, and understand each and every concepts. The third step is not to jump and start practicing, is to get interest and get a feel of real architecture. So there is an online source called AOSA book, which has different chapters written by industry experts. And what is good thing about those uh, chapters for you to start with is the chapters are written in 500 line or less, right? So you don't have to spend the entire day to understand as one architecture or get an interest and feel of it. And this is the real time lessons which industry expert have shared on this website. So let me show you what AOSA book is. So this is the website aosabook.org. Here are the chapters. You can actually click on any of the link here. So this is there are multiple chapter which I really feel is very important for someone to go through it, and I've shared in the video description as well. So you will actually feel like how the production code look like, and how what's the industrial real experience people have working with those architectures. So spend some time, maybe a week, to go through some few system design here, and then jump back for the interview preparation. Because once you have a real feel of uh, actual architecture, then it's very easy for you to, like, you can relate things, and you can know like each and every concept how it applies in the real world. So step number 4 is know the right approach. So there are multiple steps which you need to take in a specific order for a successful system design interview. The first step is requirement classification, right? You need to clarify your requirements and classify into functional requirement and non-functional requirement. Now you can give like almost like 5 minutes on that. Functional requirement can be the features, and non-functional requirement can be in terms of consistency, availability, latency, and fault tolerance. Then the second step is capacity estimation. You should spend nearly around 5 minutes on this. Like, what are the number of active users will be? How many total number of users gonna be? Storage in terms of database, cache. You can talk about bandwidth. You can talk about memory. So this is what the capacity estimation uh, there. And then you have something called third step, which is API design. You should come up with method signatures and the parameters. Make sure you follow the proper return type, and based on the functionality or based on the functional requirement which you are building. The fourth is user experience. Talk about a bit, nearly 2 to 3 minutes for the user experience. Let's say how the mobile users gonna experience these features. So if you see Instagram, in a web, there is different experience compared to a mobile, right? Because the image which you see has the way you see the image which you see on the web has different pixels compared to the image which you see on a mobile, right? And also the pagination is different in mobile devices compared to the desktop or web, right? So this is the fourth step. The fifth is you should talk about a high level design for nearly 5 minutes. So high level design is pretty simple. You just talk about you have client, you have load balancer, you have some databases. This is the request goes, comes in. Don't talk about much deeper into it like cache, sharding. So that comes in the next step, which is sixth step called component design. So there you start with your client, you talk about a load balancing, then you talk about your app servers, and then you slowly get into caching and database schema, partitioning, right? So these are the important aspects of component design. Uh, so let me take an example of Facebook newsfeed. So when you talk about component diagram or detailed component diagram for Facebook newsfeed, you start seeing like how a person posts on Facebook and how a person receive a post on Facebook. There you will talk about different sharding schemes which you're gonna have. There are different hashing which require for you to map a user to a specific shard. I cannot get deep into it right now, but I can make a separate video on Facebook newsfeed system diagram. But the important thing is you start from the first most important thing, client, then go step by step and deeper into each and every component And make sure you should not take more than 20 minutes on that, and try to cover as much as possible. Don't get into that deep as well. So if you have 20 minutes and you have, let's say, 10 components to discuss, you can spend nearly 2 minutes on that, and use that strategy like while you practice as well. So, so this is really important because people spend much of the time going to one component, like say database. They spend nearly 5 to 10 minutes, and then you will miss your caching, your other layer of system. The next step is trade-off and bottleneck. It's really, really important to discuss the trade-off of your system. You should know what are the bottlenecks of your system is, because when you end the interview, like when you finish uh, your all the points or all the steps, right? The next step is interviewer gonna ask you the trade-off, right? So if you are well prepared, if you know the trade-off clearly from the beginning when you started, right, it really helps you to have a communication on a trade-off, right? So yeah, these are the 7 steps which required for you to have a successful system design interview. The last step is practice for interview. What are the different sources that you can start practicing with? Uh, I feel the system expert by algo expert has a better content. It has a very limited content, but the way the what you can learn from the algo expert is you can see the Clement's approach, how he approach each and every problem, how he start clarifying the requirement, and how he walk through each and every 7 steps which we discussed before, right? So it's very important for you to understand how people gave the interview. So get that experience by seeing some of his videos, and their some videos are available on YouTube as well, which I can share the link in the video description. And the next resource which I can tell you is blocking the system design interview. So you can see there are multiple, all the big architectures, which is they have a content on that. So you can follow this, but make sure like before going through the content, you have a discussion. Another good resource is high scalability block, where they have a section called all-time favorite. You can just go through some of the architecture like Netflix or maybe Google or YouTube, right? So go through all the few architectures. Maybe you can just spend one day to read one architecture in the morning. That's enough, and just see like how much you can evolve. The next resource I can say is YouTube channel. You can sign up. You can subscribe to a lot of YouTube channels where people talk about the scalability and distributed architecture. So there are a few channels I have already mentioned in my video description. So please go through that. And also one point is you should practice with a timer. Don't spend let's say 2 hours or 3 hours on a specific problem. Get used to a practice, because otherwise you will fail to do it in time in a real-time interview. So if you want to know more about my system design interview experience at Amazon, Facebook, Microsoft, then please like and subscribe to my channel. All right. Thank you for watching.